In the last video, we saw that there were propositional or statement forms that individual statements can instantiate. Well, we can extend the notion of form to sets of statements, and in particular to arguments. So in this mini lecture, we're going to learn about argument forms. So remember that just as propositional forms have propositions as instances, argument forms have arguments as instances. In the right side of the slide, we have an argument form. Now remember that P and Q can be any statements whatsoever. And so this argument form has two premises and one conclusion. And so it goes like this. If P then Q, P, therefore Q. Suppose that we let P be the sentence Claire jumps, and Q the sentence Dimitri runs. Now let's go to the argument form to the right. And then wherever we see an occurrence of P, we substitute with the sentence Claire jumps. And wherever we find an occurrence of Q, we uniformly substitute with Dimitri runs. So what do we get? Exactly. We get the following argument. If Claire jumps, then Dimitri runs. 2. Claire jumps, therefore Dimitri runs. So we say that the argument to the left is an instance of the argument form to the right, or that the argument form fits the argument. Now let's start from the other end, with an argument. What we want to know is which form it instantiates. To do that, we start by identifying the component sentences. So we see that the argument is if Bill buys a new car, then Edith will be happy, but Fred will be envious. 2. Bill will buy a new car, then Edith will be happy, but Fred will be envious. And so the component sentences are basically two. One is Bill buys a car, and the other one is Edith will be happy, but Fred will be envious. And then we sign them by A and B here. So notice that while A is atomic, B is compound, right? So that we could still break it apart further by assigning a letter to each of its constituents. Namely, Edith will be happy, and the other one is Fred will be envious. But for our purposes, this level of detail is enough. So what we want to know is whether the argument to the left is an instance of the argument form on the right. In this case, we'll take our sentences and we will assign a letter to each of them. So let's assign Bill buys a car to P, and Edith will be happy, but Fred will be envious to Q. Next, we go to the argument, and wherever one of the sentences occurs, we'll replace it with the corresponding letter. And then what do we get? Well, basically, we get the form. So our original argument did fit the form, since we can go from the argument to the argument form by the uniform replacement of sentences with letters. So far, we have been saying that arguments can be valid. But this is so in a derived way, so to speak. This is because in propositional logic, it is basically argument forms that are properly said to be valid or invalid. Nevertheless, we say that a given argument is valid if two things happen. First, that the argument is an instance of a given argument form. And second, that the form that the argument instantiates is a valid form. In this case, we will say that the argument itself is valid. Now look at the argument form to the right. If P then Q, Q therefore P. Now this form is quite similar to the previous one, but it's different. The difference is that whereas in the previous one we had P in the premises and Q in the conclusion, here we had exactly the opposite. Now, is this a valid form? The way to test this is by building a truth table for it and then finding a counterexample to the argument form. Namely, a row in which both premises are true, but the conclusion is false. If we do this, which we'll do later on, we'll see that the argument form has counterexamples, and thus it is invalid. But for now, we can illustrate its invalidity by showing a clearly bad argument that fits the form. Let's replace P with am swimming and Q with am wet. What we get is the argument, if I'm swimming, I'm wet. Second, I'm wet, therefore I am swimming. This argument clearly fits the form to the right. However, it's not good because it has a clear counterexample. Suppose that it's true that if I'm swimming, I get wet, and also that I'm wet. Still, this does not guarantee that the conclusion is true, because it could be that I'm standing in the rain, obviously not swimming. So in general, any scenario in which P is false and Q is true will give you a counterexample to an argument of this form. Now we're going to put these notions together so as to see the relation between argument forms, validity, and the connective. We already mentioned that propositional logic deals with the validity of arguments when this validity depends on the behavior of the connectives. So, some argument forms are valid in virtue of the meaning of and in general of all the ways of expressing the conjunction. Consider the forms on the left of the slide. Now, which ones are valid? If it helps, you could substitute P and Q with actual sentences, such as Harry sings and Ada dances, but that is not necessary to test the validity. So take a look at the forms and try to determine whether they seem valid to you or not. So you may pause the video if you want. A surefire method for determining whether an argument form is valid is by applying the truth table test. We begin again with the columns for the conjuncts, P and Q. Then, we determine the truth values for the premise and the conclusion, depending on the values of its components. The only premise here is P and Q. Remember, because we're testing the validity of the argument P ampersand Q, therefore P. So we said that the only premise is P and Q, which is only true when both P and Q are true and false otherwise. The conclusion is P, which is identical to our leftmost column, so we can simply repeat that column. So on the third column, left to right, we have a column corresponding to the values for the premise. And in the next one, we have the values of the conclusion. Remember that an argument form is valid if and only if, whenever the premises are true, the conclusion is false. That is, if it is impossible for the premises to be true and the conclusion to be false at the same time. Correspondingly, again, an argument will be invalid if there is at least one case in which the premises are true and the conclusion is false. Now, the truth table actually cites all the possible cases, so take each row as a possible case. There are 4 possible cases, one in which both P and Q are true, one in which P is true and Q is false, and so on. So the key part of the test is to see whether there is a row in which the premise comes out true and the conclusion is false. We have to have both components, right? The truth of the premises and the falsity of the conclusion, right? And this is, again, a counterexample, those 2 elements. So let's take, there is one row, right, in which the premise is true, which is the first one, right? That's the only row in which the premise is true. Now, what about the conclusion? Is it false in that row? No, it is true. So since we have listed all of the possible cases and didn't find a counterexample, we can conclude that this argument form is valid. And indeed, you can see that it's obvious. This argument form says that whenever we have a conjunction, we can infer one of the conjuncts, in particular the left one. So if I'm having eggs and I'm having coffee, it follows that I'm having eggs. So we can start searching among the rows to see if there is any case in which the premise is true, right? And in here, there is one, namely on the first row. Let's apply the same procedure to the argument to the right, which has Q as conclusion instead of P. Again, there is only one row in which the premise is true, that is the first one. But in that precise row, the conclusion is true as well. This means that the argument doesn't have counterexamples, and therefore it is valid. Right? It's the same form as the previous one, but in this case you detach the right conjunct. In the third argument, we actually have 2 premises, right? First premise P, second premise Q, and then the conclusion is P and Q, right? And so we apply the same procedure. So there is only one, again, only one row in which both of the premises are true, which is the first one. And in that, the conclusion is also true. Okay, that's all for now. In our next mini lecture, we'll discuss other connectives besides the ampersand.